All right, so section 5. Section 5, we're continuing on with this talk on radicals and rational exponents. And so the kind of the main punchline that we talked about yesterday in our notes was that a radical or a rational exponent is essentially, it's the inverse operation or the opposite of sending something to an exponent, okay? And so we're going to be dealing with how that's used in reality, and mostly today is just going to be about illustrating how it's done. So I'm going to jump right into it. And this will be a little bit of review into yesterday. So the kind of the simplest task that you're going to be asked to do in this assignment will essentially be to translate between the two versions. So here's a radical, turn that into a rational exponent. Here's a rational exponent, turn that into a radical. Okay, and it's based off of an identity, a property that we learned yesterday, which takes a radical. And the reason this is called a radical is because that's actually the name of this symbol right here. This is called a radical. A lot of us think of it as terms of like a root, and it's tempting because of our own experiences and stuff to call that a square root. We think of that as a square root, but technically a square root means that this number is specifically 2. So more appropriately, it's called a root in general, depending on what value is here. But just the name of that symbol we call a radical. So when it says a radical, that's what it's referring to. And the identity we learned was that that can be translated into this, which is the rational exponent of that. Okay, and it's a simple translation where whatever value for the root here is, if I want to turn that into an exponent, I just put 1 over whatever that number is, and that becomes my exponent. Okay, just a couple quick demonstrations there. For instance, had I been given the cube root of 27, the third root of 27, it might ask me to convert this radical form into its rational exponent form. Or on the flip side of the coin, maybe I had something that said like, all right, 81 to the 1/4 power, which is a rational exponent or fraction exponent, translate that into its radical form. So in either case, what you're essentially doing is just cycling back and forth between these two versions. There's no difference in the value. Both can be solved in a calculator. It's just how they're written. So for instance, here, I'm going to care about what value is this. That's going to be the denominator in the exponent. So my 27, if I'm raising it to an exponent instead, now I'm going to move this guy into the denominator. And following that structure from before, it's going to be a 27 to the 1/3 power. Okay, these two are exactly equivalent. In both cases, the result would be 3, because 3 to the 3rd power is 27. Okay, for 81 to the 1/4, this is just the flip side of the same coin. Maybe basically I'm starting with a rational exponent. Now I'm moving back to a radical. So I know I'm going to need this symbol, right? The 81 is the base of the exponent. That's the piece that's going to go underneath the radical. And just the reverse here, whereas whatever this number is, that's the denominator in my rational exponent, the same goes in reverse. Whatever the denominator is in my rational exponent, that's the number that goes here as far as the root. So in this case, it'd be the 4th root of 81, which again is just a fancy way of saying what times itself 4 times will give me 81. And if I were to do that in a calculator, or just to kind of play around in my head, that would come out to be the value of 3 again. 3 times 3 times 3 times 3 would give me 81. Okay, so again, your first couple of problems will just be kind of like, all right, here's a radical, write it in rational exponent. Here's a rational exponent, write it as a radical. That's pretty much the first couple of problems. All right, let's keep going. I'm going to leave that property up there because now what we're going to be asked to do is going to be evaluate. So we're going to be basically using the same identity, but now we're going to actually have number results. And what I mean by that is like we're going to have equals some value, some number, okay? And so the next couple of problems in your assignment, we're going to be using the same identity, how to translate between radicals and rational exponents. And then we did an example like this in yesterday's notes where they told us like, all right, well, n equals something like 5 or whatever number. A equals some value that's the base of the exponent or under the radical. In this case, we'll just call it 243. It really doesn't matter what the numbers are, but basically they give us this information. They're like, all right, now evaluate this radical or this rational exponent when these values are here. So technically speaking, there are actually two different ways I could write this. I could write it as a radical, or I could write it as a rational exponent. It doesn't matter. Just pay attention to what kind of structure they want you to build into. Okay, so for instance, if they said write it as a radical, this would be the structure I'd be going into. So 5 would be the root, 243 would be underneath. And so this one would be in radical form. But if they said write it in rational exponent, again, I'm just filling in what I need to. In that case, that'd be 243 to the 1 over 5 power. Both are doing the same thing. It really doesn't matter which one's which. Just be careful on big ideas. It may ask for one form or the other. So it just matters on how it's structured. But both will have the same result. Just to remind you how to do this on a calculator. My calculator kind of uses this form. Some of your calculators may use the nth root form. So it kind of depends on what's easier for you to understand. But in my case, I have to use this rational exponent form. So I'm going to start with my base. Now, in order to do the roots or the 1 over n property here, I have to use my shift button or secondary function. And then I'm going to hit this button. And now I'm waiting to input the root or the denominator, in this case, which would be the 5th root. And that would tell me that the result is 3. And you'll get the same for either way. And what does that 3 mean? That means that had I gone in reverse or been doing the exponent property as opposed to the radical property, if I were to take 3 and raise it to the 5th power, I should get back to 243. Okay, again, that's just the reverse of that exponent property that we learned in section 4. Okay, all right, so again, we did a problem like that in the previous notes. And so this is just another illustration of that. Going to keep moving on. And next problem we're going to do, I wanted to do a demonstration. You're going to have 2 problems like this in your assignment. This is actually one of those problems. They give you a cube, hastily drawn cube. Okay. They give you a cube, and this is going to be kind of like a real-world application of this sort of thing. For whatever reason, let's say I know that the volume of this cube is something like 216 cubic centimeters. Okay. And then I also know it's a cube. So by definition, that means each of the side lengths are going to be the same. We'll call that S. And so this is what you would start with on 2 of your problems on your assignment. And so what it'll say is the actual question is, all right, based on that volume, solve for the side length S. Okay. Given this geometric figure, given this cube, we're going to use this information to solve for one of the side lengths, S. Now, essentially, you need a little background information here, like how do I solve for the volume of a cube? For the volume of a cube, it's going to be length times width times height. And so essentially here, that's going to become side times side times side equals the volume of this cube. Well, this is just another way that can be written in exponent form as s to the 3rd power, or s cubed. That's still going to equal the volume. And this actually ends up being the formula for the volume of any cube, because by definition, a cube has length, width, height of whatever side length. It's going to be some equal value. But here's why using radicals and rational exponents is used. Because in this case, my job is to solve for s. In other words, I want to get s by itself on this side of the equation, which means this cubed needs to move. And had this been any other math operation like addition, subtraction, multiplication, division, we would know the inverse operation would just be to do the opposite of that thing. Well, this is another math operation, so there is an inverse to that. And the inverse, or the opposite of raising something to an exponent, is to take the cube root, or the 3rd root of that side. Okay, so this in action is our radicals and rational exponents at work. If I have something raised to an exponent and I need to move that exponent to the other side of the equation to solve for the base, in this case, that's where I would use a rational exponent, or in this case, as I've written, a radical. Okay, and this can be rewritten as v to the 1/3 power, just using that previous concept, okay? And so in this case, now what I would do is, we already know what v is. And so in this case, that'd be the cube root of volume. In this case, we were told was 216. Or you could say 216 to the 1/3 power. Either way is fine. And so on a calculator, again, to solve for this, I would start with my 216. And then I would take the root, so I have to use my secondary function, cube root of that number, and I get 6. Okay, again, that part can be done on a calculator. And so we find out that side length is 6. 6 what? 6 centimeters. Okay, and this would end up being the final answer in this case. But this is kind of like in action why we have the radical and rational exponent in at all. Okay, it's because of something like this. If I, in typical other lessons, you would know what side length was, and then it's just a matter of like multiplying them together. Those are operations we've done for a long time. This would be a case of solving for the reverse of that. What if I know the other side and I need to solve for the base of an exponent? That's where radicals and rational exponents come into play. And again, you'll have 2 problems like that on your homework assignment. This was actually one of them, so that was kind of a free answer. All right, move on. So at this point, I'm actually going to jump to the notebook. Again, these are uploaded on Google Classroom. All right, so I'm going to talk about a single property right now, and it's this one. There's just one small twist that's been added into this property. The previous property we had said that a to the 1/n is equal to the nth root of a. But now what happens if my numerator of that rational exponent is anything other than 1? It's a simple task here. And essentially all I'm going to do is I'm going to, whatever the numerator is, raise that whole radical mess to that exponent. So where does the numerator go? It's just outside that mess. And the reverse of that, if I started with this radical mess, whatever exponent's out here would be the numerator in my rational exponent. Okay, so we're going to see problems like this now. Kind of the same progression of how to solve for these. You're going to translate, you're going to evaluate, those sorts of things. But now there's this added twist of now what happens when my numerator is anything other than 1. Technically, we were doing the same thing before. It's just that when it was a 1, whatever's raised to the 1 power just stays that thing. So it was technically being done before. It's just now we're actually talking about the numerator. Anyway, let's do this in work. So I'm going to do a couple more problems. So again, your first part of the progression is to translate between the 2 things, radicals and rational exponents. Except now I'm going to be using this property. What happens if I'm taking the nth root of a, but now that in parentheses raised to some power, call it m, right? This in radical form, because there's my radical symbol, is going to equal in rational exponent form. That's still the denominator, but now this becomes the numerator, whatever value this is. And so this is the property we're going to be basically doing time and again in this translation. Again, the practice of it is really quick, especially for these first couple problems with it, where you're just kind of rewriting one as the other. And so just a couple quick examples. If I took the 4th root of 16 and then raised it all to the 3rd power, they might ask you to rewrite this radical in terms of a rational exponent. Or on the flip side of the coin, maybe they started with, all right, here's a rational exponent, fraction exponent right there. But now rewrite this in terms of a radical. Okay, just like we did before, except now I have the added twist of a numerator that's not 1, or in this case, I have it raised to another exponent. And so the simple thing here is that there's my denominator, there's my numerator, so that 16 is raised to the 3/4 power. Okay, just basically identifying what object goes where. If I start at the opposite end of the spectrum, now I have a rational exponent, and maybe they wanted a radical instead. So I have my radical sign. That 125 is what's going to go underneath it. Just like before, the denominator is the root value that's going to be going here. So this would be the cube root or the 3rd root of 125. But now that there's a numerator, I'm going to raise that whole mess to whatever the numerator is, in this case, 5. And it's important to have these parentheses, if nothing else, just to help you with kind of the order of operations here. Because one thing you're going to also be asked to do is to evaluate. So let's say I had to evaluate or find out what the actual number answer would be at the other end of this, of taking this 125 and raising it to a 5/3 power. Well, this is important to understand, like, what do I have to do first? I have to deal with the denominator first, the root, which is to say, find the cube root or the third root of 125. What multiplied by itself 3 times gives me 125. Maybe you know, maybe you don't know. But again, we can do it in the calculator. So I would do my 125, and if I'm taking the cube root, I have to use my secondary function, cube root, and I get 5. I can confirm that 5 times 5 times 5 should get me back to 125. So the cube root of 125 is 5. So that piece is done. But now if I want to raise it all to the 5th power, I'm going to take that 5 and raise it to the 5th power. That's one where I'm not doing a root anymore. I'm actually raising it to an exponent. So that's where I'm going to use that button, just like in section 4. Now I press that one, no secondary function at all. To the 5th power, 3,125. So where did that 3,125 come from? Just to break this down, if I had to evaluate this, I would first deal with this cube root, and I would get that the cube root of 125, or what times itself 3 times gives me 125, is 5. Okay? These numbers will not always match. That's just kind of a coincidence. But I would first do this operation. That yielded 5. Now I take whatever that root value was inside the parentheses, and now I'm going to raise it to the exponent. The long way to be saying 5, 5, 5, 5, 5, right? That would come out to 3,125. So if I was asked to evaluate, that would be my final answer. For the first couple problems, you're just going to be asked to translate, so I'll just simply be typing it in either form, depending on what it asks for. Okay, all right, I'm going to move on. I have one more example for you, just a challenge problem that you'll see in your last couple of problems on this assignment. All right, so what happens when you see something like this? Okay, there's a fundamental difference here. Your last couple of problems on your homework assignment will be similar to this, where what's changed now is I still have my rational exponent. There's nothing really new there. But now what's being raised to a rational exponent, or an exponent in general, is a fraction. And so that's what's kind of changed in this case. And we're actually going to use a property from our section 4 notes right now. Basically, in section 4, it said, if I ever have a fraction raised to an exponent, regardless of what's in that exponent place, I can distribute that exponent into both numerator and denominator. Here's what I mean. So I can rewrite this as 1 to the 1/6 power on the numerator, and the denominator, 64, is also raised to the 1/6 power. This is one of the properties from section 4. Again, if I ever have a fraction raised to an exponent, both numerator and denominator are raised to that as well. Okay? And at this point, if you prefer the radical way to write this, I could also rewrite this as the 6th root of 1 over the 6th root of 64. Again, in either of those cases, I'm looking for what multiplied by itself 6 times gives me 1 and 64. And maybe you know those, maybe you don't. Again, that can be solved in the calculator. This one, I'll go ahead and spoil it. This is going to be 1. What times itself 6 times gives me 1? Well, 1 times 1 times 1 times 1 times 1 times 1 gives me 1, right? So the numerator here is going to be 1. But the denominator, again, maybe you don't know and you're uncomfortable with how to do this maybe in your head and stuff, but again, calculators come in handy for this sort of thing. So I'm going to do this on the calculator. I'm going to start with my 64. And if I want to take the 6th root of it, I have to use my alternate function here, my secondary function. And I want the 6th root of that 64, and I get 2. That can be confirmed with 2 times 2 times 2 times 2 times 2 times 2. I should get back to 64. But again, trust your calculator on that. And in this case, that meant that the denominator, the 6 through to 64, came out to be 2. There's my final answer. Okay. Again, just trust the property there that you will be coming across fractions raised to an exponent, whether it's a whole number exponent or a fraction in this case. You can distribute that exponent into both numerator and denominator, and then it's no different than any of the problems that you've done in this section so far. So that's the quick way to separate it. Okay, all right, so I'm going to stop sharing and end recording.